Okay, I've got the car depreciation dataset open in Minitab now, and we're going to have a look at some dot plots and scatter plots and then look at some correlations. So students collected this data a few years ago and they were interested in the relationship between the original price of a car and how much it was being advertised for secondhand. So these are the sort of the two main variables of interest. Obviously they were interested in the make of the car, as in whether some cars retain their value better than others. They also noted down the car yard in case that was important, the model number, I believe this is the original year of purchase, kilometres travelled, engine size, transmission type, size or type of car, and then they calculated the price change from the original to the advertised price. So if we go up to graph and we have a look at just say a dot plot, because we really need to look at the difference between a dot plot and a scatter plot. A dot plot is just going to look at one variable. If we just do a simple dot plot and we look at the original price, double click that, okay, and now we can see, I really do like the graphs more in Minitab than in SPSS. Okay. The original price, why do we have a zero value? We probably need to look at that. Unless, yes, this may be a junk car that was either given to someone or purchased for $50 or something and it's sitting at what looks like zero, but we could go through. I wonder if it will tell us what that is if we hover on it. Oh, it's coming up off screen. Let me move this across. No, I can't make it come up, sorry. Okay, so we've got some extraordinarily cheap cars and we've got one very expensive one over at around $350 or so thousand dollars. Most of the cars are falling in this sort of, I don't know, $10,000 to $50,000 range, which is probably what we would expect. And now we're interested in whether there is a correlation, whether there's a relationship between the original price and what it's being sold for secondhand, the advertised price. So the dot plot is just going to give us a look at one variable by itself. If we go back into graph and choose scatter plot, this is where we can have two together. So if I just choose a simple one, so the y is the variable that's going to go up, and usually you would pick the response variable to go up, and that would be the advertised price, as in we believe that the advertised price is responding or related to the original price. It's not hugely important if you get these the wrong way around, and sometimes there is no causation. There's not one variable causes the other, and so it's not necessarily sensible to put either, it doesn't need to be either one going up or across. Whichever one comes first, we would usually put on the x-axis. Okay. So this is showing us that it looks like there is a relationship between the original price and the advertised price. And this probably makes intuitive sense that the more you pay for a car to start with, the more it's worth when you try to sell it on secondhand. It's not a perfect correlation. If there was a perfect correlation, all we would see would be a whole lot of red dots all in a row and no scattering. Now we've got a couple of interesting observations here, this one and this one. So these cars, the original price, each dot represents one car. And if we go down from the dot, we can see what the original price was, very low, maybe between $5,000 and $10,000, and then if we go across we can see the advertised price, and in this case that looks about, I don't know, $80,000. So for these two data points, they had a very, very low buying price, but they're being advertised for high prices. I mean, $80,000 is a lot for a second-hand car. And now it's popping up the information when I hovered on it. I can see it coming up off the screen. It says the original price was $3,607 and the advertised price was $74,888, row 818. Wonder if I pull that across you can see. I do like interactive graphs where it pops up information. No, it's still coming up off screen on my other monitor. Anyway, so and then we've got this one up here. which is extraordinarily expensive. I can't fathom buying a car for $350,000. So the the original price, sorry, it's popped up off screen again. This is row 817. The original price was $4,830 and the advertised price was $350,000. So the students note in their project that they believe these two observations to be show cars or prestige cars. So they're not the ordinary buying and selling of cars. Now, if you have data points which for some reason don't really fit with the rest of your data for some good reason, then it's okay to temporarily exclude them while you analyze the rest of the data. You don't just exclude data points because they mess up your patterns, though. If they just happen to be a long way from the rest of the data and you don't have any particular reason, then that's not good enough to exclude them. In this case, these cars are what we might call ordinary buying and selling of cars, and these probably fall into a different category where they have been bought specifically to restore and put on show. So that would be a good reason to possibly exclude those. I'm not going to bother doing that here, we're just going to look at them all together. So we would expect to see a positive correlation between original and advertised price. So now if we go up into stat and basic statistics, down to correlation here, COR. Just click on the variables you want to find the correlation for. In this case, that would be advertised price and original price. We haven't got up to doing p-values yet, but you can look at those. This tells us whether or not the relationship is statistically significant, as opposed to just appearing out of random chance. And we can see here that the correlation is 0.776, which is quite high. So correlation goes from -1 to +1. -1 is a perfect negative correlation, and that would look like a downward line. +1 is a perfect positive correlation, and that would look like an upward increasing line. And 0 is no correlation, and there you would just see a random scatter of dots. And so what we have is a fairly strong positive correlation. That's getting fairly close to 1. Now, we can get Minitab to do a whole lot of correlations at the same time if we want. So let's also stick in the year, kilometres travelled, and engine size. And what we get out is a matrix of correlations. So we can look at two of them together. The top row is the correlation and the bottom row is the p-value, which tells us if it's significant, and we'll look at that in a later lecture. So we've got here we know the original price and the advertised price had a strong positive correlation. The year and the original price, so that would mean do cars become more expensive as time progresses? There is a small positive correlation. Now if we plot this, so let's delete that and put in, actually let's switch these around, because now we're interested in year along the x-axis and the original price on the y-axis. Just double click that. Okay. So there is a small upward trend. However, there were still expensive cars in the 1990s as there are expensive cars now. We also have these two very low prices, and this is probably the cars that were bought cheap and then done up as prestige cars. Now this will be affecting the correlation in this sense. This will be making it seem like there's a stronger positive correlation than there probably really is, and this might be a good time to exclude these data points if you want to take it further. So we might expect that there would be some positive correlation between year and original price just due to inflation, in that there is a small increase in car prices each year. But there is no reason to suspect that we are actually buying and selling more expensive cars as the year progresses, unless there was some, I don't know, significant change in the economy and more people were able to afford expensive cars, etc. But this will be inflating, making the correlation look stronger than it is. However, here it would still appear that there is a small upward trend, probably just due to inflation. Then we also have a negative correlation, which is nice to see. So this is with kilometres travelled and the original price and the advertised price. Now, I don't know what the interpretation is between kilometres travelled and original price. It may be that the more you pay for a car, the less you want to drive it all over the countryside. However, as far as advertised price goes, it does make sense that the more kilometres you have put on the car, the less it is worth because it's had more wear and tear. So you have to be quite careful in how you interpret correlations, and sometimes there is just a correlation in the data and there is no particular interpretation. And if you go to that website that I list in the lecture notes for this week, there's a whole website dedicated to spurious correlations where you can look at the number of divorces and how that correlates with the cheese sales in Minnesota or something like that. So it's possible that there is no sensible interpretation, and in this case I think there is one. You just have to put a bit of thought into it. So if we plot that to have a look at a negative correlation, let's just take these out. So what we believe is that the more kilometres travelled, we'll put that on the x-axis, the less we can advertise the car for, so we'll put that on the y-axis. And there is sort of a trend here. It actually is more of a curve than a straight line. What did I do? And this is just an observational data set, so you can't really draw any conclusions about cause and effect from an observational data set. You really need to run an experiment to determine cause and effect, but it does look as if there is a bit of a relationship there. Not strong. No, I don't want to save it. And then we could go and look at the engine size as a small positive correlation with advertised price and original price. Now this is a case where I don't know if engine size is really related to the resale value of a car. If anything, I would think it's these days your car is worth less if it has a really big engine. I think we're probably more interested in more efficient cars. However, it may be that the engine size affects the original price and the original price affects the advertised price. So you just need to be a little bit careful how you interpret these correlations. So this was a student project and certainly an interesting data set to poke around in. I encourage you to have a bit more of a look at this. You could go through and look at transmission, doing some other plots, not for correlation. Correlations just between the two continuous variables. But you could do some box plots and look at the size and type of car, transmission type, and maybe the price change.